Hello, Math 8 students. This is Open Up Resources, Unit 1, Lesson 9, Moves in Parallel. We have already explored the different rigid transformations, translation, reflection, and rotation, and how they work with individual figures. Now we're going to focus those same transformations and see how they affect lines. To get started, you will need some tracing paper and this actual figure printed out. Even online students, we do not have applets for this particular activity. So you'll learn best by having your own copy in front of you with materials like tracing paper. If you don't have tracing paper, you can just use a thinner piece of paper that hopefully you can see through. Either way, you will be able to do this activity. It just might take a little bit of creativity. So to get started, it says for each diagram, we're going to focus on just one diagram at a time. So for this diagram, it says describe a translation, rotation, or reflection. We're going to change that word or to and. I want you to make your brain work and describe a translation, a rotation, and a reflection that will take line L to line L prime. As we do this, we also have points A and B that are on line L. So as we perform these different transformations, we want to kind of pay attention and figure out where A prime and B prime are going to be. So your job right now is to have your paper in front of you, tracing paper in front of you, and then you'll pause the video so that you can try and find a translation, rotation, and reflection that will take line L to L prime. Pause the video now. All right, hopefully you were able to find a couple of transformations that worked. The first one is translation. So remember, when I am translating a figure, I am moving the figure without twisting it. And so, as I translate this figure, probably the easiest and most obvious way to do it is to take this line and just shift it down 3 units. And notice where A and A prime now land on L prime. So I'm going to describe this as a translate down 3 units. But I would like to point out this is not the only way that you could have done this. You also could have, I'm going to reset this, we're going to take this back to its original position, and I also could have shifted it right 1, 2, 3, 4, 5, 6, 7 and a half units. Okay, so I also could have shifted or translated right 7.5 units. One, 2, 3, 4, 5, 6, 7.5. And that's not all. There's other ways that this transformation could have happened as well. Instead of going straight down or straight to the right, we also could have done a combination and gone diagonal. For example, maybe I wanted to go down 1 unit and to the right 5 units, and notice that would have lined up those lines as well. So there are a variety of ways that we could have done this, and not one is more correct than the other, but I do think it's important to acknowledge that there are multiple ways that we could have done this. So we could have translated 1 unit right and 5 units right. Oh, I'm sorry, 1 unit down and 5 units right. So depending on how you did that transformation, you might have your points A and B in different places. So maybe this is where I'm going to have A, and this is where I'm going to have B, calling them A prime and B prime. Now, to make sure that we're fully understanding this, I do want to back up a little bit and talk about lines. You might remember from previous years that a line is infinite. Although in the diagram, that line has a beginning part and an end part, that's just because that's where the diagram ends. That's not where the line starts or where the line ends. That's why in my version of it, I have extended that line using arrows to show even though this is where the diagram ends, that line does continue. So as I move this down, notice that it's okay that this diagram stops here even though the line continues, because this line would continue. And it's okay that this line continues past where the diagram is, because that's exactly what lines would do. So one thing to make sure we are aware of is anytime we are doing any of these and the line doesn't quite line up exactly to the edge of the diagram, that's okay, because it's a line and it is going to extend infinitely anyway. Now the next challenge that we have is, can we also describe a rotation? And this one is challenging to model using the software that I have, because this is not geometry software, so it is a little bit difficult to try and model that. However, there are multiple places that we could have done that. As long as I am picking a point that is somewhere, not somewhere, but perfectly in the middle of L and L prime, I will also be able to rotate it around that point. So anywhere that's smack dab in the middle, and you'll notice that as I'm picking these various points, you will see that all of these points end up having something in common, and they're all kind of there in the middle. So again, this is not a perfect model because this is not geometry software, but if I'm rotating at 180 degrees around one of these green points, it would have ended up here. Maybe here, maybe up here, but that doesn't matter because it is a line. And so I would like to point out, depending on where you rotated, this would be your point B prime, and this would be your point A prime. So let's describe that. That is a rotation. We would rotate 180 degrees. You can say clockwise or counterclockwise, about any one of these green points. And I'm describing that as in the middle of L and L prime. Notice that I am using a cursive L here when talking about line L, because if I just do a print L, that looks like the number 1, and that can be confusing. So I am using a cursive L and a cursive L prime. And finally, for a reflection, what's interesting to note is, as I started drawing all of these green dots that we could rotate around to make L land on L prime, those also formed a line that would work for our line of reflection. Try that again. So if we use that line that goes smack dab in the middle, that would work for our line of reflection there. So reflect, we can reflect over right in between L and L prime. And I've got that modeled right here. It's kind of drawn for us. All right, now we're going to do the same thing for the second diagram. So here is the second diagram. Here is L. This time I want you to find out, can we do a translation that will take L to L prime? Can you name a rotation that will take L to L prime? And can you also write a reflection that will take L to L prime? So just like before, pause the video, experiment with your tracing paper. Can you translate it? Can you rotate it? Can you reflect it? If so, make sure you're describing that. Pause the video now. And now that we're back, I hope that you can see that there is not a translation that will take L to L prime. Knowing that I'm just sliding this, I'm not spinning it, because that's the definition of a translation, there's no way that I'll get it to be able to line up. So let's acknowledge that by saying, translation, there isn't one that's possible. Not possible to translate it. To do a rotation, This one was actually a little bit easier to identify, but to do a rotation, I'd be rotating around point A, and what I would do is I just want to rotate it this amount. So I'm going to write down rotate around point A. And I'm going to estimate that. Instead of getting out my protractor, I'm just going to estimate that. It's definitely less than 90 degrees. It even looks like it's probably less than 45 degrees. We can maybe say that that's about 40 degrees. That's just an estimate. Rotate around point A about 40 degrees clockwise. And again, remember, this isn't geometry software, so although I'm going to rotate it, I'm also going to have to move it into position 2 because it doesn't rotate around the correct point. But I can rotate it about 40 degrees. But that's going clockwise. I also can rotate it counterclockwise. It's going to have to be even more of a rotation, but I can rotate it counterclockwise. Again, think about how much that's going to be rotating then. It's going to be rotating in this direction. Again, come up with an estimate. It's more than 90 degrees now, right? And to give you a hint, if we estimated that this is 40 degrees, that full rotation that I've kind of highlighted there in orange, that's 180 degrees. I know that because it's a straight line or a straight angle. So if this whole thing is 180 degrees, this amount is 40, then I think it's safe to bet that this amount here is about 140 degrees. So, or rotate around point A about 140 degrees counterclockwise. And now to reflection. There are actually 2 lines of reflection here. Again, they're best if I draw them for you so that you can see them. All right, looks like, let me get those the right color as well. Both of these lines go through point A, and they act as a mirror because we can see that B would be reflected down to here, A would be reflected up to here, or A, I guess, is where those lines go through. So let me describe it and then I will model that first. So reflect over the vertical line that goes through A. Let me model that one first. Here's that vertical line that goes through A, so I can take this and flip it left and right. And again, remember, not geometry software, so it's not flipping it exactly the way that it should. But we can see that it does flip directly onto there. And we can also flip this over the horizontal line that goes through A. And again, remember, not geometry software, so it looks like it's not happening correctly, but it is. And we can see where that point ends up as well. So we can say, or reflect over the horizontal line through A. Okay, now that's kind of our warm-up to really get our brains thinking. Now, what we're going to be doing is doing some transformations with a set of parallel lines. So as we continue on, I want you to, again, trace this onto some tracing paper or to some really thin paper. We have a set of parallel lines now. A is parallel to B, and we have point K, which is on line B. We're going to be doing these different transformations, and I just want you guys to just watch instead of pausing and trying to do them on your own, especially because you might not have access to the tracing paper and those other tools. Just watch the video as I perform them. Pause the video if you're taking notes and you're wanting to get those drawn on your own notes, but just continue to play the video, pausing only when you need to. To get started, we have lines A and B, and we are supposed to translate lines A and B 3 units up and 2 units to the right. Now, although we have point K is a hard point to reference when we're trying to translate up 3 units, because if I go up 3 units, I am now off of that grid. So I've got this extra point here, and that extra point is a little bit easier to follow. Then I can go up 3 units and 2 units to the right, just like it says in the direction, which means that this red point is going to go up 3 and 2 red, which means all of everything else is too. So you can see those parallel lines moved up 3 and 2 units right. What are some things that are the same and what are some things that are different? There are a bunch of things that I want you to recognize. First, I want you to notice that both line A and B have a new position. However, although lines A and B have a new position, I do want you to recognize that there are a lot of things that are the same. For example, we can see that lines A and B are still parallel. Which means that they're still the same distance apart. And we can also see that they are still going in the same direction. And all of that is important to note because that also means that they are still parallel to the original lines. Now, what if I didn't translate it that same amount? I'm going to give you another example. What if it was here and I simply translate that? Let's go this way. Let's translate this direction. Notice that that is in a new place, and I know that because this red point was right here, and now I'm translating it here. So I did perform a translation, but those lines stayed exactly on those lines. So sometimes you will see that happen, and that's going to come up again in our summary. Now, let's take a look at the next one, which I'm going to do on a new slide, but now we're going to rotate lines A and B. So again, the notes that I wrote for translate just disappeared. It's because I'm on a new slide so that I can do this rotation. It says rotate lines A and B counterclockwise 180 degrees using K as the center. So again, remember, as I'm doing this rotation, this is not geometry software. Normally what you would do is you would poke a hole through your tracing paper so that you can just spin that paper around. We're going to model it a little bit differently, and this isn't geometry software, so I have to rotate it and then move it. But essentially what we're doing is we're rotating counterclockwise, which means I'm going this direction 180 degrees. But since I'm rotating it around point K, that means point K didn't change. So it should look like this when you've rotated using that tracing paper. So a few things to observe here. Notice that because I rotated around point K and point K was on line B, when I spun it around 180 degrees, line B is still line B. It stayed exactly the same. A, however, did rotate into a new position. We would call that one A prime. So again, let's write down some of the things that we're observing, what's the same and what's different. What I noticed is that B is still line B. And it's still line B because we rotated around K, which was on B. So that is important to note. What are some things that are the same? Oh, that was something that was the same, but it kind of goes along with something that's different. I'm going to make sure I note A is in a new spot. So although B stayed the same, A is in a new spot. Other things to mention, same types of things that we mentioned before with our translation, and that is that these are still lines. They're still parallel lines. Something that's important is that they are still going in the same direction. And that also means that they are still the same distance apart. All important things to know about rotating those lines. And again, I want to emphasize that B stayed on B because we rotated around a point that was on B. Normally, that's not always going to be the case, just like we saw with our very first problem, our warm-up, where we could rotate around any of the points in between, and then it came into a new position. And now our final one, again, you're going to see these notes disappear because I'm moving on to a new slide, so that we can finally finish and talk about reflecting lines A and B across line H. So what I would do to perform this is we would need to have H on our tracing paper, and then we would need to flip it over H, which is kind of hard to do. Sometimes it's easier to fold it. But here is what that is going to look like. And again, remember, not geometry software, so it's going to look a little bit weird. Here it is. Again, remember, I know it looks weird because it's not geometry software. So it looks like I'm having to rotate it too, but it's only those things that I have to kind of manipulate because it's not geometry software. Okay, looks like it's roughly in that position. Here's how I'm going to check to make sure that I've done it correctly. I know that when I stand and look into a mirror, I'm looking directly at it, and I know that the reflection is going to be that same distance away but on the other side. So it looks like I need to move that just a little bit closer. Technology. There we go. That's a little bit better. Some things to note. Notice that A was originally on top. It was the highest line. But in the reflection, now A, which I'm going to go ahead and call A prime, that's now the lowest spot. So B is closer to the line, so it makes sense that B is going to be closer to the line. But it's interesting to see how that flip-flopped. It's because those reflections are opposites, right? It's the opposite image, or a backwards copy. And so what was the highest is now going to be the lowest. And this would be the B prime. So again, those are some things to note in what is the same and what is different. What are the changes that occur? I would say A was the highest, or was on top, but the reflection shows A on the bottom. Other things to note, we are going to notice that both A and B are in a new position this time. But some things that are the same, they are still lines, which seems so obvious, but it's one of the really important geometric foundations as we continue on, so it's still worth mentioning. When I reflect a line, it still is a line. The lines are still parallel, which means that they are the same distance apart. And they're still going the same direction. And now here is your "Are you ready for more?" The image that you see on your paper or on your screen in Canvas, it kind of looks like this, but what you're going to see is I'm going to take these lines and I'm going to rotate them just like it says. It says when you rotate two parallel lines, sometimes the two original lines intersect, and their images form a quadrilateral. What is the most specific thing you can say about this quadrilateral? So I'm going to rotate this so you can see how it works. I'm rotating those. You can still see those lines here, but you can also see the rotated, and you could see that rotation actually take place. So what is that most specific thing that I can say about this image? And I want you to be really careful. Why are we saying that? Is it always going to be that, or is it just this time that it's going to be that? Give yourself a second to think about it and pause the video if you need extra time. The most specific thing that I can say is that it is a rhombus. And be careful, students in class said that you can say it's a rhombus because it looks like a diamond. And that doesn't show a precise understanding of the word rhombus and what a rhombus is. Remember that a rhombus is a four-sided figure with each side the same length. All four sides would be the same length. And we know that they're all the same length because they're parallel. So we know that that side is going to be equal to that side, and this side is going to be equal to that side. And again, it's because we understand the definition of rhombus and not just because it looks like it is a diamond. If I were to continue, so again, I want you to focus on that blue and the black. Don't worry about the grayed image behind it. If I were to continue, you can see that eventually we can make a square, right? We can get to those 90-degree angles, but it's not always going to be a square. And so that's why the most specific thing I can say is just that it's a rhombus. Again, remember, a rhombus because all side lengths are the same. All right, as I continue on, just remember, pause the video if you need time to think or to write. If you want to do this before I show you how to do it in the video, now would be the time to pause it. But what we're going to do here is we are going to rotate this line 180 degrees around point D. So again, just like before, not geometry software, so after I do that rotation, I have to move it into place. And you can see that where B was, you can now see B prime. I'm just going to go ahead and label it to be B prime instead of just B. And D stayed the same. This isn't C anymore because C is over here, so this is C prime, and this isn't A anymore. This is A prime. So it's kind of interesting to see what happened as I rotated that, how it changed the order of the points, but not really, right? A and then C, and when I look at it, we can see A and C. So it's the same points that have just been kind of rotated all the way around, and so it's kind of in the same order, but if I'm reading it left to right, it might look backwards. This one is the most important one from the whole lesson today, and that is we have these two lines, L and M. Notice that line M is on point D is on line M, and point A is on line L. And what I'm going to do is it says rotate the figure 180 degrees around O, and we need to make sure that we relabel our new A and D. So let's go ahead and do that. We're rotating this 180 degrees, and just like you've heard me say before, please remember that this is not geometry software, so after I rotate it, I really do need to get it back into place. And when you perform that rotation on your own, it should have looked like this. And so this was A, it was rotated 180 degrees, so this is now A prime. And this was D, but it was rotated 180 degrees, and so this is now D prime. And the final question that we have is, what do you know about the relationship between the angles in the figure? This is actually addressing something that was on your pre-assessment. And we maybe don't know the measure of the angles. I can see this right here. But I know that when I rotated AOD, that rotated into this position here. And so I can see that that angle that I've colored in purple is going to be the same as this angle here. So whatever this angle measure is, which I don't know, it is going to be the same as this angle measure here. That's really important to note. So I'm going to write that down, and I'm going to say angle AOD is the same as angle A prime O D prime. Now mathematicians are lazy, so I am going to use some mathematical shorthand. I'm going to write the exact same thing, but using some mathematical shorthand. Is the same as, we're going to represent with this symbol here. And that symbol is called congruent. It's like equal, but it's a geometric term when we're talking about two figures being the same. So angle AOD, again angle, I'm lazy, so I'm going to use this symbol here to represent angle. AOD is the same as, or is congruent to, angle A prime O D prime. So this is in English. This is in math symbols because we're lazy, and so we like to try and shorten those kinds of things. And I also would like to point out that this is so important, it has its own name. It's called vertical angles. And that's the relationship. Vertical angles are congruent. That's going to come up in the summary as well. Vertical angles are congruent. And we can see that because we rotated this angle so that it was this angle, and that's how we know that they are congruent. I also would like to point out this angle here and this angle here are also vertical angles. So I could even list that out and say angle DOA prime is the same as or is congruent to angle D prime OA. So even these green angles here are congruent to the green angles. And now it is time for our lesson summary, so I'm going to start highlighting. What we saw is that rigid transformations, any rigid transformation, rotation, reflection, or translation, will all take a line to a line. That means if I have a line and I rotate it, it still is going to be a line. If I have a line and reflect it, it still is going to be a line. Might be in a new position, but a line is still going to be a line. A rigid transformation of two parallel lines results in two parallel lines that are still the same distance apart as the original two lines. So we saw that again, that when I rotated, reflected, or translated the parallel lines, they still were parallel lines. And sometimes a rigid transformation takes a line to itself. And this is a little bit hard to describe, so I'm going to just show you. We can see this line here. And what if I translated it in the direction of this arrow or in the direction of that vector? Well, then that translates to right here. And it is still a line. It's the same line. Sometimes you will see that happen, like a translation of a line parallel to that line. So we went in that same direction. A rotation 180 degrees around any point is going to land that line back onto itself. So as long as that point that we're rotating around is on the line, then it's going to rotate onto itself. And this is the last one, a reflection across any line perpendicular. That is a word that was also on your pre-assessment and you do need to know. Perpendicular means right angles. So if lines are perpendicular, that means that they form right angles with each other. So we can see in the image above, this dotted line is that mirror line. Notice that it is perpendicular, meaning it forms a right angle there. And so A is staring straight into the mirror, and so A prime is staring straight back. And so we can see that this reflection of the line, it takes that line right back onto itself. These facts help us make an important conclusion. If two lines intersect at a point, which we call O, then a 180 degree rotation of the lines with center O shows that vertical angles are congruent. That's what we wrote down on that last page. And again, make sure you understand these here. Those are vertical angles. It's kind of hard to describe. It would almost be like saying the angles that are on opposite sides of each other. But understand that these are vertical angles. And vertical angles are congruent, meaning they have the same measure. That is our new glossary term, vertical angles, and it leads directly into our lesson cool down. So here we have A prime, B prime, and C prime formed by rotating A, B, and C 180 degrees around this point O. So part 1 says name a segment that is the same length as AO. So here's how long AO is. How long, or find another segment that would be that same length. And step 2, what is the measure of angle A prime, O, B prime? So A prime, O, B prime, what is the measure of that angle there? To answer the first question, we can see that AO is this length, and since it was rotated 180 degrees, we can also see that A prime O is that same length. Whatever it is, it's the same length. And what is the measure of angle A prime OB? Well, we can see here that we've got vertical angles, so we can recognize that that is 79 degrees. And it doesn't ask, but we could also do the same and understand that 35 degrees for this angle, so the vertical angle associated with that would also be 35 degrees. Other things worth mentioning, understand that this whole entire angle here is 180 degrees because it's a straight angle, forms a straight line. So if this is 79 degrees and this is 35 degrees, we also can identify and understand that this angle here, all of it would have to add up to 180. Since that's 79 and that's 35, this would be 66 degrees, which means vertical angles, we could also find that angle and understand that it's 66 degrees as well. That's it for today. Lesson 9 practice problems are your homework. For online users, this can be completed in Canvas. However, there might be some times where you need a piece of paper to answer the question on your own, and then you can type in your response into Canvas. That's it for today. Have a good one, and we'll see you next time.